Hi everybody, this is going to be our first Unit 4 video, and this is really just going to be a factoring refresher. We're going to look at 4 different types of factoring. You've seen all of these in Algebra 1. It's just a refresher. So let's just jump into it here. Let's start off with a GCF. Now, you should always look for a GCF anytime you go to factor. There's not always going to be one that you can factor out that's helpful, but you should always start by looking for a GCF. And in this case, we're going to have a GCF between the numbers and the x's and the y's. So first, we need to decide what is the biggest number that is a factor of both 40 and 64. Okay, well, 8 can come out of both of those. That's the biggest number that's a factor of each. With variables, especially here when I have an x to the 8th and an x to the 4th power, we can only take out the smaller of the two powers. So we're going to factor out x to the 4th, and then both of these terms have a y that we're going to factor out as well. So when we factor out our GCF of 8x to the 4th y, we're going to go back and divide each of our original terms by that GCF. So when we go back and do that, we're going to be left with 5 x to the 4th plus 8, and that's it. Okay, you can always check to see if you properly factored out the GCF by redistributing that GCF and check to make sure that when you multiply everything back together, you get the proper answer, okay? Meaning you get what you started with. So what you see in green here is your final factored form. Okay, what I want you to also get in the habit of is counting the number of terms. Okay, if you see 3 terms and you notice that you have a leading coefficient of 1, then you're going to factor this using your x. Now you probably remember from Algebra 1 that when we have a trinomial like this, we are looking for 2 numbers that multiply to 26 and add together to make negative 15. We just use the x to organize our thoughts. Okay, so we need to think. It multiplies to make a positive, adds together to make a negative. That means both of our numbers must be negatives. Okay, and those 2 numbers are going to be negative 2 and negative 13. They multiply to make positive 26, add to make negative 15. So now I can simply factor this into w minus 2 is w minus 13. So that's probably the type that you remember the most from Algebra 1. That's the kind that you saw the most often. Okay, let's see another one of those. Again, I notice there's 3 terms. My leading coefficient is a 1. So I'm going to factor this with my x. So I need to find 2 numbers that multiply to positive 1 and add to negative 2. Okay? You're always multiplying to find the c value and adding to find the b value here. Okay, if you think about the quadratic standard form. So in this case, my 2 numbers are going to be negative 1 and negative 1. So now I can factor this into n minus 1 times n minus 1, or we could write that as n minus 1 squared. Now this time, I notice that I have 3 terms, so it's a trinomial, but my leading coefficient isn't a 1. So what I'm going to try is, I want to see if I can factor out a GCF here. And I notice that with all of my numbers, I can factor out a 5. So I'm going to factor out a 5 and see what I'm left with. Okay, so here's what I get. So what I'm going to do now is I'm going to look at what's left over inside of the parentheses here. I notice it's a trinomial. I notice that there's now a 1 in front of the z squared. So I'm going to try to factor this like I did the previous trinomials. Find 2 numbers that multiply to 6 and add to negative 5. So my 2 numbers are going to be negative 2 and negative 3. And what you have to be careful about here is that GCF of 5 that we factored out is going to stay there, but what I have underlined in green is going to factor into z minus 2 times z minus 3. And this would be our complete factored form. You can't forget about the GCF you factored out at the beginning. Sometimes, though, we'll have a trinomial where there is a number in front of x squared, but we can't factor it out. Okay, I can't factor 12 out of this expression. There's actually no GCF other than 1. So this takes us to a different type of problem. We're going to have to factor this by grouping. The issue is that grouping requires us to have 4 terms, and we only have 3. So we're going to have to split that middle term, 5x, into 2 parts. Okay, we'll have 12x squared plus something, and then minus 2. So we need to figure out what the 5x is going to split into. And here's how we do that. We're going to use the x, but we're going to use it a little bit differently. Instead of finding 2 numbers that multiply to -2, and those same 2 numbers that have to add to 5, we're going to multiply the first and the last number, 12 times -2. So that would give us -24. And add to 5. So we need to find numbers that multiply to -4, add to +5. So that's going to be a +8 and a -3. And I'm going to use those values to split 5x. 5x is going to split into a +8x and a -3x. Okay, because if I recombined those 2 terms right there, that's going to give me my original 5x. The reason we're doing it this way, though, is so that we have our 4 terms and we can now factor by grouping. So factoring by grouping is really easy. I group the first 2 and the last 2 together. Notice I included the negative with the 3x. With grouping, it always needs to be addition between our 2 groups. Once we have our groups, we factor the GCF out of each. So my first group has a GCF of 4x. When I factor it out, I'm left with 3x plus 2. My second group has a GCF of -1. And when I factor that out, I'm left with 3x plus 2. If you remember from Algebra 1, when you factor by grouping, what's left after you factor out the GCFs should always match. Okay? What we do now is we factor out the 3x plus 2 from each group. That makes our first factor. Our second factor is going to be made up from those GCFs that we factored out already. So 4x minus 1. And this would be your final factored form. So those are a lot trickier. You have to be on the lookout for those. Okay, the last type we're going to look at are differences of squares. These are very easy to factor if you recognize that's the kind of factoring that you're doing. Okay, difference of squares has a formula. Okay, if you have something in the form a squared minus b squared, it factors into a plus b times a minus b. Okay, well, we just need to figure out what a and b are, and then we can factor it really easily with this formula. To get y squared, I'm squaring y. To get 81, I'm squaring 9. So this is really acting like the a and the b in that formula. Notice that minus sign stays in the middle. It's not, we're not treating it like a -81, we're just thinking of it as minus positive 81. Okay, to get 81, it's 9 squared. That minus has to stay in the middle. Once we have this, we can look at our formula. We know it's a plus b times a minus b. So it factors into y plus 9 times y minus 9. And that's it. Okay, we can also do this with multiple variables. To get m squared n squared, I need to square mn. And to get 49, I need to square 7. So again, I have my a and my b, and we can use that formula. Mn plus 7 times Mn minus 7. All right, guys, so that is it for our factoring refresher. again, this is all stuff you saw in Algebra 1. I wanted to go through the main types because we are going to use this to solve quadratic equations down the road. So let me know if you have questions, and have a great day.